can't see the pages too well. It could be that my eyes are getting weak.
Oh, wow, that was a good one.
Now you'll see. He's going to tell us the Greeks invented thunder and electricity.
No, the Chinese. Things always begin with them.
Now, you think so, do you? And you think that you know it all?
No, Maestro. No, we're not like him.
No. Hold it, that's enough. You're going to ruin a tremendous story again.
Go on, tell us, Maestro. Tell us a story.
Well, all right. But first of all, it's far too dark. Suppose we switch on some light.
There's nothing very complicated in that. You press on the button and then there is light. It's as easy as 1, 2, 3.
Yeah, yes, that's what everybody always says. Every dunce, easy as 1, 2, 3. And yet, scientists, even some of the greatest, Einstein included, all admitted being perplexed by the phenomenon of electricity. Yeah, but electricity wasn't invented. No, in fact, it's always existed before prehistory.
That was a big one, that one was. Look there. It set the forest on fire.
Who would ever have thought that lightning was electricity? That it could prove useful, but then one day, 3,500 years ago.
That's it. Now we get the Greeks.
I tell you, it's the Chinese.
On to the promised land. These are the commandments of the Lord, our most precious possession, which we carry in the Ark of the Covenant.
The ark will have to be in heavy stone, so the commandments will not be stolen.
No, my friend. It will have to be light. We must be able to carry it easily. But the treasure contained inside we must protect.
How then?
You will see. Pure gold. The outside and the inside of the ark must be covered with gold.
But why the inside? No one will see it.
Just for added protection. Now we may all sleep soundly.
The Hebrews are asleep.
Yeah, their great treasure is in that box.
Their greatest treasure, he said.
Nothing can stop us now.
Good work, Moses. How'd you do that?
That is a mystery that mankind will understand 2,000 years from now.
Hey, be careful, Moses. The ark is very dangerous. Look at those two.
Only those with impure hearts will be struck down. We are in no danger.
Is it true, Maestro? It happened just like that?
Was it magic?
Was it electricity?
The Hebrews knew all about electricity?
Well, the ancients knew a great many things. Moses had just invented the condenser, giving an electric shock to anyone touching the sacred ark.
Then why didn't Moses get a shock?
Because Moses had a ground wire.
A ground wire? You mean he was earthed?
Exactly. You recall, the golden threads of his sacred robe touched the ground. The Chinese were familiar with the magnetic needles and were the first to make a compass.
Points always in the same direction. It could be useful for staying on course during a voyage. I'm going that way.
Well, I'm...
It's me who keeps the compass.
An Englishman, Francis Hawksby, invented the first mercury lamp without really understanding it, and it was soon forgotten. A Dutchman, Pieter Muizenbroek, invented the Leyden jar that would store electrical charge. It was a shocking event. A Frenchman, the Abbé Nollet, invented all kinds of games.
I shall charge the ball with electricity. There we are now. I will pass the electricity into this iron chain.
In America, Benjamin Franklin was also studying electricity.
Lightning will come down all the way to the key, you see? Now I know lightning is only a form of electricity. Now I know how to protect buildings from being struck by lightning.
In Russia, another scientist heard about Franklin's lightning rod.
There we are, Franklin's lightning rod.
Professor Reichman, careful. You've got it wrong.
How would you know? You're not a scientist, are you?
No, but I still... I told you. You forgot it has to be grounded. Earth, sir.
Professor Reichman was killed instantly. And this accident should help you to understand how important earthing can be in a house. Wait, I'll show you something. No, not that. Not that. No, that's my lunch. At last. As you know, the current passes through these two pins, but this one is connected to the earth. That's how we avoid being struck by lightning.
Oh. But lightning, Maestro, what is it exactly?
Well, that is pretty simple. As Michael Faraday would demonstrate, the Earth is an electromagnetic mass. The ground carries negative charge. Above, there's a layer of dry air, the troposphere, which does not conduct electrical current. And still higher is the ionosphere, mainly carrying positive charges. They're called ions. A storm cloud gathers positive charges on top and negative charges on the bottom. And the delayed meeting of these ion elements will spark off a tremendous thunderbolt. In Italy, in Bologna, a scientist named Galvani was also interested in electricity.
What are you doing, Lucia?
I'm boiling frog broth for Signora.
Va bene. Oh, what is it, Lucia?
It's the frogs, sir. They're jumping.
What a notion. Those frogs are all quite dead.
There. They moved again. They twitch whenever you turn your machine, Signor Galvani.
Curious that. You turn the machine, I'll watch. Go on, turn it.
No, Signor Galvani. Your experiment is of utmost interest, but I do not believe the frog stores up a reserve of animal electricity. It's different metals which are acting on the frog's legs, and if you wish, I will prove it. A disc of copper, another of zinc. I put a damp cloth.
Ow!
One of copper, one of zinc, and a damp cloth. Another disc of zinc, and here's the result.
Volta had invented the battery. Fundamentally important. Well, we use batteries every day of our lives and never give it a second thought. Yes, and batteries have millions of uses.
Eh? What's wrong? I was doing an experiment.
Lightning, the compass needle, frogs' legs that move. All that is still electricity. But still, nobody really knew what it was exactly or just what to do with it. But then along came a young Englishman, Michael Faraday.
All right, Michael, that's enough for today.
This is all we have for dinner.
You know times are hard, children. Mr. Rebo, my son Michael is a hard-working, honest lad. He knows how to read and do figures. He might be useful to you.
He's a good-looking lad. I'll give him a try. To begin with, you'll deliver newspapers. Here you are. This is your day's work.
Not much work for a whole day.
Oh, there you're wrong. You see, my newspapers aren't for sale. I rent them. So you see, the first one you deliver to Mr. White, and while he's reading it, you deliver the second to Mr. Bland, and the third to Mr. Tyne. The fourth, it goes to Mr. Roll. Meantime, go back and collect Mr. White's paper and take it to Mr. Black.
Which paper, sir?
Come back later. I haven't finished.
You're a hard-working lad, Michael. I'll take you on as an apprentice binder. We have to make new bindings for these encyclopedias.
Oh.
They are very important. Well, Michael, you haven't finished the work.
Oh, I'm sorry, sir, but I happened to see this article on electricity. Apparently, it's a sort of vibration, a bit like heat. I'm pretty sure that nobody really knows what it is.
And you? Do you know what it is?
No, but I can try to find out.
Ah. Look here, Michael. You can read all the books you like, but you'll have to stay late and finish that work.
Oh, thank you, sir. I will, sir.
Public lecture by the scientist Sir Humphrey Davy. With demonstrations.
Young man, stop your pushing. You wouldn't understand it
What?
anyway.
I'm sure I'll understand it as well as
What
you do.
effrontery!
Electricity is a phenomenon that is extraordinary. Look. All this is not thoroughly understood. Perhaps my experiments will add something to solving the mystery of electricity. There we go. Way. So. No! Oh, my goodness, I can't see anymore. Oh, yes, the notes you sent to Mr. Faraday are pertinent. And so, young man, you want to work in science?
Yes, Mr. Davy, that's what I want.
That's a thankless job, badly paid, and sometimes dangerous. You still interested?
Oh, yes, I am.
Very well. Since I need an assistant, I'll hire you a trial. You will receive 1 guinea per week and have a room over the laboratory, aprons and candles, and you will start tomorrow. We're going to work with nitrogen trichloride to try and disintegrate this substance. And put this mask on, the headgear, and hold this tube. Now, first, we'll prepare a small quantity of trichloride. Now, slowly mix all of them up. Slowly, very slowly. Slowly. Oh! Wait, I'll make the mixture. Place the tube there. Whoa! This time we're going to succeed. We'll increase them, all the quantities.
Yes, sir.
Oh! All these accidents won't prevent their traveling in 1814 to Rome.
Ah, these are very special fish. They make a very powerful electricity.
May I touch them? Funny. Very funny.
We're going to study this, Mr. Faraday.
In 1820 in Denmark, a scientist, Ørsted, is going to perform an experiment that will change Faraday's life and the lives of all humanity.
There's a relationship between magnetism and electricity. Look at this compass. The needle points north. If I push it, it returns to the north. But if I produce in its vicinity an electric current, then this needle is deflected. You see, it turns. The closer I come with this wire, the more it moves from the north.
But if electricity and magnetism are really expressions of a single force, if they're the same, yes, that could be it. Good heavens, I'll be late. I've got to hurry.
Mr. Faraday, have you any notion of the time?
I'm very sorry, Mr. Bernard. I was caught up in my work.
We expected you at 5 o'clock. My daughter Sarah was quite put out. Now, well, come in.
Tell Mr. Faraday that I do not wish to see him or speak to him.
My sister Sarah wishes to inform you.
I heard what Miss Sarah said. Sarah, please excuse me. I'm sorry.
Edward, I said I do not wish to speak to Mr. Faraday.
But
she says...
Oh, please. Oh, Sarah, The attraction of love is like that of a magnet. There is an induction generating movement. It's like that. Oh, please excuse me. It's important. I must go.
Scientists comprehend many things, but they don't understand love.
Into a basin of mercury, I place a magnet vertically. An electric wire here is pinned to a small cork to make it float. The other wire here into the mercury. I connect the wires to a battery, it turns. It turns around, it turns. There is a magnet, but I really don't need it because the Earth itself is a magnet. That can only mean the world is full of electrical and magnetic currents that interact. The force is electromagnetic.
Michael, dinner is ready and waiting.
Wait, I have an idea. Come here, I want to show you something.
But the dinner...
Just for a few minutes. Come with me, quickly. In here.
You showed it to me already.
Only think. If electricity creates movement, then movement should be able to create electricity. Now, turn the crank, Sarah, please.
It's marvelous, Michael. It's so pretty. How did you do it?
Here, I'll explain it. Look, Sarah.
Dinner will be burnt. Explain it to me later.
Here's how it works. There are lines of force. No rubbing and no contact. Not a matter here of static electricity, but the movement of the magnet creates a field of force which produces electricity.
My poor Michael, do you really believe that? You, with no education, no scientific background, and not knowing mathematics, you'd make such a discovery?
Why do you say that? Why does my master say that?
It was my idea. He stole it.
Well, that is certainly a more likely explanation.
In any event, the machine does appear to create electricity. Can any of you gentlemen explain how it does so?
Well,
Gentlemen, it's because the Earth itself is an electrical and a magnetic field. The compass proves this by pointing north. Lightning, which passes from clouds to the Earth, is conducting electricity. I think there are particles which are displaced. I named these ions.
These particles, these ions? What an imagination!
Any friction is going to rub electrical particles off the amber. The amber wants them back, so to speak, or to find other particles. It attracts them. And particles form fields in the air everywhere. They induce a current through this copper wire.
What is it? Why are we running for our lives like this?
We're ions. All together, we make up an electric current. All of us ions are negative. You guys.
You mean there's others?
Sure, it's positive. The girls.
And what do the girls do?
Same thing we do, but they go in the opposite direction. Hey, take a look.
Yeah, you're right. It's crazy. The two of us never meet.
We do now and then, but I warn you, it's a shocker. Watch it. We're coming to the end of the wire.
Hold on. Now's the time. We're gonna meet the girls and sparks are gonna fly. Hooray! I caused an induction of an electrical current.
It doesn't look astounding. But that disk turning in a field of magnetic lines of force was one of the greatest inventions of the century. The first dynamo, and soon electrical generators would appear everywhere.
Yes, Maestro. We understand how electricity is used to make light and all that. But what is it exactly, electricity?
To simplify, let's say that it's an energy that is a part of matter and whose particles attract or repel each other. That's what happened to the ions that you saw earlier. Now, you take magnetism. Let's look at two magnets. You see, like poles push away, unlike attract. Electricity is also, if you like, a twin sister to lightning. But to harness it requires a conductor of some sort.
And Maestro, tell us, how big is an ion?
1 million ions, can you imagine them?
Oh, sure. Well, sort of.
Mm-hmm. And 1 million times 1 million? Can you imagine that?
Well, that's kind of hard.
Yes, it's very hard, eh? Well, 1 million times 1 million ions wouldn't cover the head of a pin.
Question.
Yes, ask your question.
How fast can these ions move then?
Oh, no faster than the speed of light. 300,000 kilometers in 1 second. The distance of the moon from the Earth. Electricity is something about which we don't know a great deal. And even I don't. And there we are. So I'd rather imagine that it's a fairy. That is a massive force that man has managed to liberate. Oh, yes, it was with Faraday that the universe of Newton would end and the notion of bodies attracting and repelling each other. The world would be seen as a field of forces producing electricity. It is to Faraday and other discoverers that we owe the understanding of electrical energy. And without that energy, well, our world wouldn't be anything like what it is today. Don't you think he deserves a loud cheer, kids? This Michael Faraday, who was just a simple blacksmith's son?